If you found yourself stuck in a situation like me, where you got multiple inputs to read, let's say for example 8 buttons, and you have to read them separately, but you own a microcontroller, like here I got a PIC12F683, which has 8 pins, and hasn't the ability to read more than 6 inputs. You wonder how you're gonna deal with that? Okay, stay tuned guys, because I got the solution for you. In this video, we will discuss multiplexers, how they work, how many types are there, and let's speak about every practical example of them. First things first, let me tell you that there is 2 types of multiplexers, the analog and the digital type. Some analog multiplexers can accept analog and digital data, such as the 4051, which can handle both signals. Alright, let's move in deep and try to figure out how they work. Multiplexers are basically a selection system. The idea is that they switch a targeted input from many, and depending on some given address, they put it on the output. Let's clear this with an example, shall we? I want the input 6 to be connected to the output pin, so I have to tell the selector that I want the input 6, and simply apply number 6 coded in binary. Considering S1 to be the MSB, that means that S1 will get 1, S2 will get 1, and S3 will get 0. Like that we will have a 6. You have to be aware that multiplexers are different. Some ones are 4 to 1, some ones are 8 to 1, and the other ones are 16 to 1. What's the difference, you may ask? Well, it's simple. A 4 to 1 multiplexer got 4 inputs and 1 output, and 2 selection lines, because 2 power 2 is 4 inputs. Please note that the variety of 4 to 1 devices contain 2 separate multiplexers inside one chip. Again, 8 to 1 multiplexer got 8 inputs, 1 single output, and 3 selection lines, because 2 power 3 is 8. Now, I just wanted to mention that a multiplexer can work as a demultiplexer. That means that we can invert the function of a multiplexer and make it work in the opposite way, as a demultiplexer. That's it. If you followed all what I've explained, you can consider yourself familiar with those components. Now let's make something useful out of multiplexer. I'm gonna be using the 4051, which is an 8 to 1 multiplexer. I have decided to use the board that I have made earlier. This board simplifies the connection and bring all the lines to one single bus. The data input pins are here, VCC and ground in the middle, and from this side we have the address pins and the output. You don't have to worry about the enable pin because it's already connected to the ground in my design. And if you are a follower in my Instagram, you obviously know why I decided to make this board and where did I use it. And if you aren't a follower yet, I put a link to you in the description that takes you directly to my Instagram account. Check it if you want, that would be cool. There's also a link to schematics, board layouts, codes, and link from where I order my PCBs down below in the description. For the functioning part, I hooked a wire to VCC and another wire to ground. Then I applied power to the board. Next, I've decided to add a dip switch to the address lines. I took my input right from the signal generator, so I connected a wire to it. Finally, I applied square wave signal with a frequency of 1 Hz. And after choosing the right address in my example, binary 1-1, the output got multiplexed to the input 5. Awesome! For the microcontroller part, I'll be using the PIC12F683, as I have said earlier, to read multiple inputs. Remember that we were generating the addresses with the dip switch before. Now I want the microcontroller to generate them for us. With the help of the logic analyzer, now you can see how the PIC increments the address bus, starting from GPIO 0 to GPIO 2. So for that address bus, we need 3 pins. We also need our dip switch for inputs. I connected the output of the MUX to GPIO 5. And finally, this LED on GPIO 4 lights when all the switches are closed. After uploading the code with a programmer, let's close all the switches and try our system. And as you can see, the 8 inputs have been successfully read. Neat! That was exciting, isn't it? Well, we got a problem. The PIC12F683 has very limited features, so I present you this 60 inputs out of an Atmega 328P, the Arduino microcontroller. This beastie contains an MP3 DF player that plays 60 tracks for every button pressed, which makes it a good example of multiplexers.
1, 2, 3, 4, 5, 6.
So that's it guys for this video. I hope you learned something new. If yes, like, subscribe, and share it with your friends so we can all learn together. Stay tuned for the next video and goodbye.